Welcome to the Deep Dive. Today, we're digging into a really fascinating story. We're looking at excerpts from Gustaf Komppa, the alchemist of Finland.
Yeah, and our mission here is to pull out the key insights, tell the story of this chemist. From Finland, a smaller nation then, scientifically speaking.
But he dared to challenge the big scientific players of his day. It's quite the tale.
Absolutely. It's about this young guy with just this intense curiosity, turning like a shed into a lab.
Right, a carrot shed, and eventually achieving something people thought was, well, pretty much impossible. It's a story packed with challenges, but also perseverance and breakthroughs.
Definitely. So where do we begin?
Okay, let's set the scene. We're in Viipuri, Finland, late 1800s. And you have to picture it. Finland, back then, it wasn't, a major center for scientific discovery like Germany or France.
Not at all. Resources were tight. Getting access to, say, advanced labs or even higher education wasn't straightforward.
It really wasn't a place brimming with scientific privilege, let's say.
Exactly. But that's where we find young Gustaf Komppa. The source describes him as just relentlessly curious, always asking questions.
That why and how impulse.
Right. And he didn't just wait around for a fancy lab to appear. This is where the carriage shed comes in, his carriage shed laboratory.
It's such a great image. He literally took this probably quite basic outbuilding and just made it his own little world of chemistry.
Yeah, think about the sheer will behind that. Makeshift setup. Probably working by candlelight, Basic beakers, the smell of chemicals.
Definitely not state-of-the-art. Built with curiosity, not grants.
And he wasn't just mixing things randomly, right? He had a guide, a book.
Yeah, Julius Adolf Stuckhart's Schule der Chemie, School of Chemistry. That one book sort of lit the way in that shed, gave him some structure.
It's amazing how one resource can be so powerful. It kind of shows that, learning doesn't only happen in formal classrooms.
True. And it makes you wonder, doesn't it? How do we look at our own starting points? Our own, maybe, carriage sheds?
Do we see them just as limitations? Or could they be, like for Komppa, the very place where big dreams start, where you have to get creative?
So, he had this spark. But turning that into a formal education in Finland, you mentioned it was tough. Like climbing a mountain, the source says.
It really was a challenge. Access was limited, but he did it. He graduated from Helsinki University of Technology in 1891, a major step.
That showed he could navigate the system, get that formal knowledge.
But he knew, didn't he, that he needed more. To really compete, he had to go where the cutting-edge stuff was happening.
Right, so his next move was crucial, going abroad.
To Switzerland, yeah. To work with a big name, Arthur Hansch, a leader in organic chemistry.
So this wasn't just about getting another qualification. This was about absorbing innovation.
Absolutely. Learning the latest techniques, the newest theories, getting himself right to the forefront of global chemistry research. Sharpening his tools, basically.
And he needed those sharp tools because the field he was about to jump into, well, was intense. Early 20th century chemistry.
Oh, incredibly competitive. A real global race was on.
Centered around one particular substance.
Yeah.
Camphor.
Camphor, exactly. And you have to understand, camphor wasn't just some obscure compound. It was hugely important.
Why? What was it used for?
Well, several critical things. Medicine, for one, used in all sorts of treatments and salves. Then explosives. Very important strategically, especially with the political climate heating up.
And plastics, right? The source mentions plastics.
Yes, the brand new plastics industry, particularly celluloid, think early film, billiard balls, things like that. Camphor was essential for making it.
So massive demand. But there was a supply problem.
Big time. Natural camphor came mainly from camphor trees in East Asia, and supplies were just dwindling, getting expensive, hard to rely on.
Which created this huge push.
To synthesize it, to make it entirely in the lab from simple chemicals. Whoever could do that first would solve a major global problem and likely make a fortune.
So the race was on. Who could crack the code for synthetic camphor?
And we're talking the heavy hitters here. Labs in Germany, other major European centers. Backed by industry, staffed by the top chemists of the day, pouring resources into it.
And into this high-stakes, high-resource race, Komppa comes back to Finland.
Yeah, back to his home country. Relatively small, scientifically speaking. Fewer resources than the giants he was up against.
His decision to even try to enter this race from Helsinki, it seems incredibly bold.
Audacious is the word. It really begs the question, could he actually pull it off? Could a Finnish chemist really compete on this level?
So he gets back. What were the immediate challenges The source calls it a crucible.
Well, first there was skepticism, doubt from abroad, maybe even some at home. Could a Finn really beat the Germans at their own game?
And the practical stuff,
Yeah.
the labs in Finland compared to, say, Germany.
Oh, much more modest, you'd imagine. Limited equipment, maybe trouble getting the right chemicals quickly, just harder logistically. Every step was probably tougher, more constrained.
So he had fewer resources, more hurdles.
Exactly, but the source frames this interestingly. It suggests that adversity almost became his ally. It forced him to be smarter, maybe.
More innovative out of necessity.
Perhaps. More persistent, certainly. He couldn't just throw money at problems. He had to think his way through them. He worked incredibly hard. Long hours, sometimes alone.
But he also had students working with him.
Yes, he inspired a small group, people drawn to his vision, his sheer determination.
And all that hard work against those odds, it eventually paid off.
It did, the breakthrough moment. 1903, Gustaf Komppa achieves the world's first total synthesis of camphor.
Total synthesis.
Right.
Meaning from basic chemical building blocks, right? Not
Yeah.
just modifying something close.
Exactly. Starting from simple, readily available materials and building up that complex camphor molecule step by step.
Can you give a sense, for those of us who aren't chemists, why camphor was so difficult to make from scratch? What was the big challenge?
Sure, it's about the structure. Camphor isn't just a simple chain or flat ring. It's got this complex 3D shape, a bridged bicyclic structure. Imagine loops connected by an extra bridge.
Okay, sounds intricate.
It is. Getting all the atoms in exactly the right place in 3 dimensions, using the chemical reactions available back then, that was pushing the limits of organic synthesis, a real molecular puzzle.
So being the first to solve that puzzle, that must have made some waves.
Huge waves, shock waves, really, through the scientific world. This chemist from Finland had beaten the big German labs, the established titans.
There must have been disbelief.
Controversy.
Oh, absolutely. Disbelief, probably some envy too. How did he do it? But his work was meticulous. He published it. It stood up to scrutiny. History clearly shows he was the first.
And what's really striking is he didn't just stop there. He didn't just publish the paper and say, job done.
No, not at all. He immediately thought about the practical side, how to make this useful, commercially viable.
Which led him to a different approach, not the total synthesis for industry. Right. He realized that while total synthesis was the ultimate scientific feat, it might not be the cheapest way to make camphor in bulk. So he developed a semi-synthetic process.
Semi-synthetic, meaning starting with something closer to camphor.
Exactly. He used pine, which is abundant in tall oil.
And tall oil is.
A byproduct of making paper pulp, something Finland had plenty of thanks to its forests. Pine structure is already quite similar to camphor's.
So it's fewer chemical steps to convert pine to camphor.
Far fewer, much more economical for large-scale production at that time. It was brilliant, really.
Using a local Finnish resource to commercialize his global scientific breakthrough, that's smart on multiple levels.
Definitely. It meant his discovery wasn't just academic, it could actually be used, scaled up. It helped provide a reliable synthetic source of camphor, impacting industries.
But his impact didn't end with camphor, did it?
Yeah.
The source mentions other work. Peat.
Yeah, peat. Another resource Finland has in abundance, but often overlooked, just seen as, well, bog fuel.
What did he do with it?
He developed ways to convert peat into high-octane fuel. This was incredibly important for Finland's modernization, helping with energy needs using a local resource.
So it shows his vision extended beyond just pure chemistry to, like, applied industrial chemistry for national benefit.
Absolutely, solving real-world problems using chemistry. And he was also committed to building the foundation for future science in Finland.
Like finishing the chemistry lab at the Helsinki Polytechnic Institute.
Yes, when his mentor fell ill, Komppa stepped up in 1898 to make sure that new important lab facility got completed. That wasn't just admin, it was building infrastructure for the next generation, a commitment beyond his own bench work.
So when you look back, the ripples from his work are pretty wide.
Yeah, they really are. Making medicines and materials more accessible through camphor, helping modernize Finland's economy with the peat-to-fuel work.
And shaping education, too. First professor of organic chemistry, chancellor at Turku University later on. He was influencing both science and industry leadership.
He got international recognition, too. Honorary degrees from across Europe, founding member of the Finnish Academy of Science and Letters, served on company boards, clear signs of his stature.
But maybe, reading between the lines of the source, the biggest legacy isn't just the chemistry, it's the inspiration.
I think that's right. It's that spark he ignited. The belief he demonstrated that where you start doesn't dictate where you finish. that you can face down huge challenges and achieve something extraordinary.
That dreams aren't too audacious, obstacles aren't insurmountable.
It's a powerful message, goes way beyond chemistry. It's about human potential.
And that really brings it back to us, to you listening. The source uses these great metaphors, Komppa, as a lighthouse, a beacon.
Yeah, showing the way, even when it's difficult.
Right.
And it taunts the question, where are your carriage sheds? What are those places or situations in your life that seem humble, maybe inadequate?
Could they actually be the start of something big if you just began?
And what are the metaphorical mountains you're facing? In your work, your learning, your projects, Kompa's story doesn't pretend it's easy, but it insists it's possible.
You have to remember the pushback he got, too. The skepticism. People questioning if a Finn could do it, questioning his methods.
He faced all that, but he kept going. His work was the answer. And that persistence, that's why his life is framed as this alchemy of perseverance.
It's a neat formula, they suggest. Adversity plus perseverance equals breakthrough.
It doesn't romanticize hardship, but it says when you meet adversity with that relentless effort, that's when transformation, the alchemy, can happen.
It's a really strong reminder that greatness isn't just for the privileged. It's often forged through challenge, by the grit needed to just keep pushing.
So maybe the final thought, the challenge from Kompa's story to you, the listener, is this. What is your camphor?
What's that big goal, that audacious challenge that's calling to you? The one that feels maybe a bit impossible right now.
Kompa's journey from that shed to the world stage, it shows what's possible. It's really an invitation to think about your own potential breakthroughs.
To dare to start. And maybe even more importantly, dare to keep going when it gets tough, when the path is steep or people doubt you.
Exactly. Dare to begin and dare to persist. Kompa proved it can be done. The world, it might just be waiting for your breakthrough. What's it going to be?